It's bits to atoms and atoms to bits, or data to things and things to data. Meaning, a thing doesn't have to be a product. A product is a thing, but a thing doesn't have to be a product. The best way to understand the research I'm doing is communication was analog. It degraded with distance. It was digitized, and we now have the internet. Computation was analog, and it degraded with time. Analog computers, the answer got worse as time progressed, and we now have digital computers. The most advanced manufacturing today is analog, meaning the design is digital, and what you're building might be digital, but there's no information in the materials. It's analog in exactly that same sense. Whereas life is digital. Life builds exactly with codes in the way you understand it, but the code doesn't describe a thing, the code becomes a thing. And so the research we're doing is how to do that, how to turn codes literally into things. And I can tell you about that research, but then the implications are like the spread of the internet. It enables anybody, roughly anybody, anywhere to make almost anything. So Fab Labs, NSF, the National Science Foundation, asked me to do some outreach, tell people what we're doing. And we thought it'd be more interesting to give access to the tools rather than talk about them. And so today a Fab Lab fills a room, about the size of the room we're in now. And there's a misconception. It includes a 3D printer, but it weighs about 2 tons and costs $100,000 because it includes many other machines. And today, if you wanted to make a computer, a bicycle, you need not just a 3D printer, but a number of different machines. And so a Fab Lab is like a snapshot of all of that technology. To understand its role, in the mini computer era when the internet was born, a computer filled a room. And the computer was divided into many parts, but you could sort of call all of that a computer. So in the same sense, think of the Fab Lab as a machine, but it's actually 10 machines in the room. The research is to squish it all into one machine, but like the growth of the internet, you don't need to wait. And so we just set up one as a community project, and that led to another, and that led to another, and every time one opens, somebody else wants one. And so the result is they've been doubling for a year and a half, with a doubling time of a year and a half or a decade. And so we went from 1 to 1,000, and now we're looking at the next date of going from 1,000 to 1,000,000. So this, of course, is a very emotional time for anybody from America with the election. And what's very frustrating, but also a cause for hope, is the election was really all about diverging economies, people left behind, the failure of jobs. And it was fought over which candidate would be better at bringing back the jobs. And what's emerging from this digital fabrication revolution and the spread of Fab Labs is a very different and a very new notion of work. Instead of going to do something you don't want to do to get money to then get something made far away, you can sustainably produce locally, and it really changes the notion of how an economy works and what a job is. France is a good example. Fab Labs have been spreading in a network all over France. And what's driving it is there's kind of a rigid hierarchy of what you learn in education and what you can do in business. And bright, inventive people growing up in France often aren't excited by the educational or business opportunities. They're building this new notion of how an economy works.